All right, good morning. We are doing math again today. 2.1 rates of change and the derivative. Find equations for the tangent line and the normal line to the graph of the function. Find the rate of change of a function. Find the average velocity of an instantaneous velocity. Find the derivative of a function at a number. So, tangent line. Okay, tangent line to the graph at point P, continue to point P. So right here, so having the slope. So basically I'm using this formula, the limit process, to find the slope. Remember M stands for slope, right, in my equation. Y equals mx plus b. So M stands for slope. Okay, so provided that the limit exists. So now for this to work out, the limit has to exist, and what else? Has to be continuous. It has to be continuous over that. Okay, so now, provided the limit exists, so here's no notation of it. So this is f prime of c. That means that we have the derivative of that. So we have the derivative of it there. So that's basically what we're trying to find. So we're finding the slope of the tangent line, but another way of writing that is f prime of c, which is going to be the derivative at a point. If m tan, so that means the slope of the tangent exists. Bless you. Wow. All right. So then an equation of the tangent line to the graph at the point P is this. Now this is another way of actually writing it. So where this right here is the slope, right? It's the slope. This is the point slope formula. And this is the y value. So this is usually y minus y1 equals m quantity x minus x1. That's the point slope. That's another way of writing it. So, but they're just writing it given the notation that we're using here. So f of c, that means plugging in c to my function to get my y value. And then c is just the x value that I have, where m is the slope at that point. The line perpendicular to the tangent. Okay, it's perpendicular to the tangent at the point P of a graph. Function is called the normal line. Normal line. Perpendicular to the tangent. Okay? So, perpendicular. You guys ready? Get your arms ready. You ready? Okay, sine wave, get ready. Okay? Gotta do a sine wave to get ready. Especially if you just got here. Sine wave to get ready. There we go. Alright, so perpendicular is going to be, come on. There we go. Yes, thank you. Alright. Yeah, so it's going to be perpendicular there. Okay, to the graph at point P. An equation of the normal line to the graph of a function y equals f of x at the point P is, now, remember, perpendicular. The slopes are going to be opposite and reciprocal. So, I know you just wrote that down because that is very important. We know that the slopes are going to be opposite and reciprocal. The opposite and reciprocal. So if my slope starts off as 1 over 4, the opposite reciprocal would be a negative 4 over 1. Right? Yes. Okay, good. All right. So provided f prime of c exists and the equation is not equal to 0, if f prime of c, so the derivative, is equal to 0, the tangent line is horizontal. Okay? It's horizontal, and the normal line is vertical. Okay? A vertical line, we get something like this. X is equal to that number. Remember, vertical line. Okay, the slope is undefined, right? The vertical line test, you remember the vertical line test? So it would be vertical, so it would be undefined slope. So it would be 1 over 0. So it's rising, but it has no left or right. So it's over 0. So that would be undefined, so we get an equation like this, which is x is equal to c. It's not a y equals function, it's an x equals c. Okay, investigate an infinite limit. Find the slope of the tangent line of the graph here at c equals -2. Okay, so let's go back. So let's find the slope. So that is x squared. So we're using this one right here. Right? Say yes.
Yes.
Okay, good. So f of x minus f of c minus, or I'm sorry, all over x minus c. So f of x is going to be x squared minus f of c. What is my f of c? What am I going to do with the c value? I'm going to plug it in, right? I'm going to plug that into my function, so that would be my f of c would be what? Positive 4?
Yeah.
It's going to be positive 4, right? Because if I plug in negative 2 here to my x squared, I'm going to get a positive 4 over, okay, x minus c. So that's going to be what? Right? Because if it's minus c, it's minus a negative, so I get that there. And this is my limit as x approaches c, right? Okay? So now, on that top, what do I got to do with that top? I'm about ready to use an F word. Factor. There we go. Factor it, right? Wrong F word over there. All right, so it's going to be x plus 2, x minus 2, all over x plus 2, right? There we go. Okay, so what can I do? Cancel my what? There we go, and I'm left with x minus 2, right? Okay, so now can I take the limit as it approaches c? Yes, I can. Now I can plug in that number, right? Now I can plug in the number negative 2. So if I plug in negative 2, this is going to give me what? Negative 4. So, to go back full circle, that my slope of my tangent is equal to the limit as x approaches my c value, which is negative 4. Okay, another way to write this notation would be f prime of negative 2 is negative 4. Now, this is my slope. Now, you guys already get your arms all warmed up? Okay, you guys ready? Warm up the arms again. Okay, sine waves, sine waves. Okay, so x squared, my f of x is equal to x squared. So what shape is that? Let's see those hands. X squared, parabola, right? Come on, make the shape, thank you. We have a parabola, don't we? So it's going to be opening up, and it's a parabola. Now, if I think about that, is that right? So if it's going to be a parabola, something like this, at negative 2, is my slope right here, my slope right there, do you think that should be a negative 4?
No.
Is my slope right there going down? Yes, it is, right? Okay, look, right here, this is slope. So it's a bad sketch, but I'm trying here. So at negative 2, it says my slope is negative 4, right? Negative, a negative slope means it's going down. Is that steep enough to look like it could be going, yeah, down 4 over 1, right? Yeah, okay, that is correct. So you guys gotta think about it. You gotta imagine the shape. What is it supposed to be? This is what it's saying. That at that point, if I draw a tangent line, the slope would be this. Okay, so let's see where we're at now. All right, so we have here, find the slope of the tangent line. Okay, we got that. Now, this next part says, use the results from A to find an equation of the tangent line. Okay, So we're going to find the equation of the tangent line next. Okay, so I'm going to clean this up a bit. So we know that f prime of -2 is -4. Okay, so now I need a coordinate. I know that my slope is equal to -4. But I need a point, don't I? What is my x value I have? -2, -2. Do I know the y value? What's the y value going to be? No. Remember, the y value is just going to be your f of c right here, right? It's the f of c. So I'm going to take my -2 and plug it in right here, so I get a 4, positive 4. So now I have an x, I have my y, and I have the slope. So I'm going to plug it into my point slope, so it's going to be y minus 4 equals -4 quantity x minus -2. Okay, so let's keep going. So this is going to be y minus 4 equals, distribute, so it's -4x, and that's going to be -8. Yes? Okay, what am I doing to both sides? Add 4. So y equals -4x minus 4. So there is my equation of the what? It's not just the slope. Tangent. This is the equation of the tangent line. Yeah? Are we okay? So that's the equation of the tangent line. So the next thing I'm going to do, let's look, find the equation of the normal line. Okay, so now, okay, it's at the same point. So I have that point. So, change this up. So my perpendicular slope for this, what's going to be the perpendicular slope for -4? Perpendicular slope for -4. 1/4. So it's positive, right? So it's going to be a positive 1/4. So it was opposite and reciprocal, right? So now it gives us my point right here, which is -2, 4. So do the same thing again. So y minus 4 equals 1/4x x minus -2. Where am I getting what?
That. Like, what's it put it?
This?
Yes.
Okay, this right here, this is y minus y1 equals m quantity x minus x1, and this came from right here. So at this point right here. Thank you. Keep it wet. All right, are we okay now?
Yeah.
Okay, so that's where I got those from.
What's the thing with the 1/4?
This right here? Oh, this is the symbol for perpendicular. Upside down T. Upside down T, that's my perpendicular symbol. Okay? So, let's go ahead and do our math on that one. So it's going to be y minus 4 equals 1/4 x, and that's going to become plus 1/2. Right? Okay, so I gotta add that 4 to both sides, right? Add the 4, so it's gonna be y equals 1/4 x. So if I'm adding 4, so it's plus 1/2 and plus 8/2. You guys okay on that one? Okay. All I did is I made it have common denominator, right? 8/2 is still 4, isn't it? Okay, so now I can put those together. So that's going to give me y equals 1/4 x plus 9/2.
And that's your answer?
Yeah, that's for the,
Tangent line?
nope,
Normal line.
normal line.
So, not the slope, not the tangent, the normal line.
Normal line. Okay, you're going to have a lot of those. Okay, now graph F, the tangent line, and the normal line at those points on the same set of axes. So you guys are going to help me with this because I'm going to put in the calculator. So let's see what we have here. So we have, what was the first one? -4, right?
Yeah.
So it was -4x minus 4? Was that the tangent?
Yeah. Or
Yeah, -4 is -4.
Okay. There's that one. And now let's do it again. So hit tab. So my next one is going to be 1/4, right? Over 4x plus 9/2. There you go. So these things right here are going to be perpendicular to each other at that point, which was -2 and 4. All right? Did you guys graph that? Hopefully. All right. Let's take a look at. I think I leave you guys. No, I think it's after this one. Yeah. Okay, so average rate of change. So average rate is basically just delta x or delta y over delta x. So it's the same thing that we did there, okay, where x cannot equal c. So if x is equal to c, what do I end up with the bottom? 0. Can't have that, right? Definition of instantaneous rate of change. Instantaneous rate of change of f at c is the limit as x approaches c of the average rate of change. Symbolically, the instantaneous rate of change of f at c is this, provided that the limit exists. So we're trying to actually figure out where it goes from here to here. Find the rate of change from here to here at 2 or any real number. Okay, let's start with that 2. Okay, so if I'm doing the limit as x approaches c, right, my c value, which is going to be 2, it's going to be x squared minus 5x minus my f of 2. What's that going to be?
4 minus 10.
4 minus 10, which gives me all over
X minus
2, right? Okay, so now let's see, it's going to be x squared minus 5x plus 6 over x minus 2. Now, I'm about ready to say one of those F words again that we love so much.
Factor.
Factor it. So what are we going to get for a factor?
X minus 5x and then x plus 5x.
X minus 3, X minus
There we go.
yeah,
Because
it is.
they're right here. Since there's a plus sign right there, that means that they both have to have the same sign, all right? So that's going to give me a x minus 3, x minus 2 over x minus 2.
Cancel out.
Yep, I can
X minus
cancel,
2.
right? So I could do this now. Limit as x approaches my 2 value of x minus 3, which is going to give me, what do we get?
Negative
-1.
1.
Yes?
Yeah.
Okay. So that wasn't too bad, right? Now for this next part right here, we're going to do the exact same thing, but this time we're going to do any real number C. So let's see. So if it's any real number C, it's going to be x squared minus 5x minus, let me see, that's going to be c squared minus 5c over x minus c, right? Yeah? Okay. So let's see. So that's going to be x squared minus 5x minus c squared minus plus 5c over x minus c. So basically, for any real number, what do I need to do? So any real number with this right here, what would I do? Just plug in a c value, right? So any real number I choose, if I want to find it at like the number 5, what would I do? Apply 5 in for my c's, right? And then it will work out. And it will. Nice and neat, hopefully. Yes, yes it will, nice and neat. Okay? Alright, so that was it for that. Okay, so I'm going to leave you guys off there. We're going to pick up the rest tomorrow. Don't forget, like and subscribe. Hit that notification bell.